All right, great. So we're gonna be going over the balance parentheses challenge. This is a pretty good algorithm, so I think it's a fun one to kind of go through. The goal of this is to implement a function that takes in a string, it looks like, and we want to return a string that has balance parentheses. So what do we mean by that? We mean that for every opening round parentheses that we have, we want to have closing parentheses after it at some point. If we have extras, for example, the second line here, let me make this a little larger maybe. The second line here, we have an extra one at the end. That's extra closing parentheses. There's no matching equivalent opening parentheses before it because this parentheses that I've highlighted after the B, that is the one that's closing the first parentheses. So this one is extra. Therefore, your output string should omit that extra extraneous closing parentheses. Likewise, you can, if you have an opening parentheses before you encounter a closing parentheses, that should be omitted. So this one does not have a matching buddy ahead of it. Therefore, we want to drop it off. And this one has no matching buddy after it because it's the opening one. So we also drop that one. So in that case, return empty string. Yeah, so hopefully the requirements for this one was pretty clear. We gave you plenty of test cases. So hopefully that was useful to you guys. Let's kind of get into it. So I'm going to first fork this over. Put that into my personal GitHub. Let that do its thing. All right, there we go. I'm going to copy that URL and then go to my terminal here. So I'm going to do git clone, paste that URL in here. Okay, cool. That was pretty quick. And then I'm going to code algo balance parentheses. All right, so VS Code should pop up there. I'm going to maximize that and shift that over to be over. I think I need to brighten my screen here. Okay, cool. So we read the README. I like reading it on the web browser for whatever reason. I don't like this README here. So we went over the README. We're going to be solving this in Python because, again, as mentioned, kind of going forward for the next couple of weeks at least, we're going to be focusing on Python. So probably good to focus on Python. So first, I'll write my test cases. Right? We talked about test-driven development. So let's get our test cases kind of going here. Let me maybe query the audience here. So Sean, what do I need to import to use the test case framework in Python? Do you remember it offhand?
Yeah, you need to import unit test.
Yep, you got it. Again, nothing that you have to memorize, but more and more you do it, hopefully you guys kind of understand what we got to do. To get this started, we need to have this statement down here. So if leave is main, do I have that reversed?
Name.
Again, this is just to kind of initialize the testing framework. So we want to do unit test. Okay, cool. So that will initialize it. Now we have some rudimentary test cases here where we're just doing print statements. Again, those work, but we kind of want to have this a little more robust. So we'll put this into our test case setup here. All right, so does anyone remember how I do this? What do I need to create here?
You should create a class called maybe balance parents test case and inherit from the unit test.test case.
Yep, absolutely. So let's call it balance friends test cases. And yeah, we need to inherit. So again, we haven't talked about classes too much or inheritance. That's what we're going to cover this week. So we kind of got ahead of the curve here, but we kind of just told you to kind of accept it by understanding that unit test.test case kind of provides some magic for us, and then we add on top of that magic for whatever else we want to use from the test case. So here we're going to create some methods. These are each of these methods will be a test case. Remember, we want to start the name of these methods with test. Otherwise, the unit test framework will identify it as test case. And then let's name these test cases. So let's say tests. I'm not sure how to name these. So balanced parens simple one. Always, we need to pass this self as the first parameter. That will be kind of demystified as we talk about classes today and the rest of this week. But for now, we have self, and then we want to do, let's say, assert equals. All right, so I'm going to take this first print statement that we were given. And so balance parens should return something. And then expected output. Okay, so we want to assert equals. Since these are strings, we can compare them. Assert equals expected. All right, so that was one test case, pretty straightforward. Again, just kind of remember the key parts. First, you want to import unit test. Second, I like to kind of just get this out of the way, set up this initializing statement where we check if we're in the main module, we want to initialize unit test by calling .main, the method main on unit test. Step 3 is create a class that inherits from unit test. So it's easy to forget this. And if you don't do this, none of this is going to work. Like it just won't have, it won't know what assert equal is because that's coming from the test case. It won't know kind of how to run your test suite. So again, remember to inherit by adding unit.testcase in parentheses attached to your class name. And again, this is an example of inheritance, one of the core object-oriented programming concepts that we'll talk about, I think, on Wednesday this week. All right, so this is my class, my test suite, and then I have a test case here. Remember, you want to create a method via the def keyword. Your method name should start with test. The unit test framework kind of looks for methods that start with test. All right, so that is one test case. Let me add a few more. And then always remember when you're writing test cases, think about those edge cases. So I think one thing we want to test for might be test empty output. So sometimes we might get an empty output. I think we had an example of that in our README. So I'm going to just copy that. So we have this. And then our expected output should be empty string, as we talked about. So we have a closing parentheses before any matching opening one and an opening one without trailing closing one. So both of those will get chopped off. So this would be our test case, output 1. So we talked about empty output. What about we had an empty input? So if we have empty input, obviously our expected output should be the same. So empty input. Again, just cover all your bases. Again, you're not going to cover every iteration or every possibility, but just cover every bucket that you can. So I'm going to add a few more here. Let me put these up here. Any questions about setting up our unit test framework? Okay, so have a few more test cases here. I'm going to add one more. I'm going to go a little more complicated. So we have nested. That'll be maybe a advanced thing we need to do. Like this. So I'm just trying to have my naming a little consistent, but all over the place here. All right, so this was my inputs, nested parentheses, and output should be, let's see, this one gets chopped off, that one gets chopped off. All right, cool. All right, I have some test cases here. I have a couple simple ones where we kind of just have non-nested parentheses, have one for nested. Maybe want to add one more nested one, but for now I'm good. This one is where we get an empty output. So nothing's returned, and then we have an empty input. So just, again, testing any possible edge cases. Let's do one more maybe. What if we had no parentheses at all, but we had some strings? So we had A, B, C, D, E, F, nothing in there. So we should return the same thing, A, B, C, D, E, F. All right, I think I'm good with my test cases here. So I'm actually going to just run my test cases right now and see what happens. Maybe I'll pass one accidentally, but I wouldn't expect to pass any of them necessarily. Ooh, I like this one. I'm going to add this one in. All right, so where did that go? Simple. nested. All right, this will be our last one. I think we've got enough test cases here. So nested 2. Drop
And
that
real
in
quick,
there.
there's 2 empty output ones.
I can't get anything by you guys, but no, I appreciate that. Thank you. Also, I know a couple of you guys spotted that one of our challenges wasn't linked properly. You guys are great at catching our mistakes. So that should be fixed for today. I think Guillermo, you pointed that out. Thanks for that. All right, cool. So have my test cases, have about 10, maybe 8 test cases. Let's give them a run. So to run this, I'm gonna run my spec file, and that's all I have to do for unit tests. I don't know how to run anything else. So maybe bring in my terminal with control tilde. There's my terminal. I am in my Python folder, so need to be in the correct folder. So cd Python, and then I'll do Python balance parens spec. Run that. All right, ran 7 tests. I probably failed all of them. Yep, I got 7 Fs, so that's not that's expected because we don't have any logic in here. What was that thing I want to talk about? So fail fast. Yeah. So there's this command that you could add on to your test cases called fail fast. That's kind of useful, especially when you have probably like dozens of test cases. Fail fast will basically run your solution, and then it'll abort on the first failure of a test case. So it won't keep running all the test cases if it runs into one failure. And this is kind of useful for where you want to incrementally fix one test case, make sure it works, and then move on to the next one. And kind of instead of kind of having like a long laundry list of 10 failed test cases, and then kind of maybe for me at least kind of confused me like, all right, what do I focus on? This allows you to have the test suite abort on the first failure. So that's -- fail fast as one word. And as I say, when I ran it, notice I ran 1 test. Since it failed that test, it didn't go on with running anymore. All right, so let's get to our algorithm. So obviously we have nothing coded here, but our task here is to solve this challenge. So first thing, and this is something again I would definitely want to encourage, is to pseudocode. So this challenge is definitely a little more involved, maybe compared to some of the other challenges from week 1. So this one I think is very, very well suited to pseudocoding. So yeah, let's kind of code this together. I'm gonna call on someone because I love hearing from you guys. Who haven't I talked to last week? I feel like there's definitely some people I need to chat with. Who's out there? Sorry, just scanning my feed here. Like I've talked to most of you guys. Jordan, I feel like Jordan. Have we chatted last week? I don't even know. I know we were in the office, but Jordan, if you can kind of help me pseudocode this, I'd appreciate it. So, what are your thoughts on solving this algorithm? What steps should we take?
So first, you would want to set a empty string variable.
Okay. So again, right now we're just pseudocoding, so you can write up our kind of mindset or game plan in comments, and then we'll kind of fill in our code from that. So yeah, we should start with a string because that's probably one return. So let's say return a string.
And then probably loop through the input string.
Okay. What are we going to be doing inside that loop?
We're going to be looking for parentheses.
Okay. Yeah. Find parens, and then let's say we find parens. What do you want to ideally do with them?
Maybe keep a count.
Okay. What is this count gonna actually like? How are we gonna use this count? What are we gonna count up? Each opening and closing parentheses? Are we gonna have 2 different counters? What do you think?
Probably 2 different counters.
All right, so we'll keep running count of opening and closing parentheses. Okay. Ignore. All right, anything else our loop might need to do here?
We'd need to add any missing closing parentheses or opening.
Sorry, say that again. We need to add.
To the answer string.
Okay, gotcha. Yeah. So append or yeah, add. So what are we going to add here?
Either a missing closing or opening parentheses.
Missing close. So just to clarify, I think for the requirements of the problem, I don't think we're going to add closing parentheses. So for example, this example, we could add an opening parentheses here at the very start, or I guess anywhere to match this buddy. But I think we just want to trim off extraneous parentheses. Yep. So how would we actually go about kind of trimming off the extraneous parentheses? So
I'm
basically right
not
now we're
sure.
going through our string, we are finding the parentheses and keeping account of how many opening and closing ones we find. Question for you, Jordan, or if anyone else wants to kind of chime in here. So we're going to keep account of opening and closing, but again, we also have a requirement where every closing parentheses has to come after, sorry, and a closing parentheses has to have a matching opening parentheses before it, as in there's some sequence there. So how might we kind of keep track of that with our counter maybe?
Can I, do we want to compare how many open parentheses versus the total of closing parentheses we have?
Yeah, so we definitely need some comparison, compare opening count to closing count. But I think we still might have an issue, and maybe we could kind of tackle this as we start coding. But my thing I have in mind is, what if we have, an example where our string is, closing, 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 opening, opening, opening. Well, in this case, we're going to have equal numbers, right? We have 3 closing, 3 opening. But the problem here is the closing ones must come after an opening one, as in for every, sorry, it's hard to say, every closing parentheses, there must be a matching opening parentheses before it. So in this case, this string would kind of work with our initial thought process here, but we need to have something so that we can actually check there's opening parentheses.
Hey, Unkar.
Yep.
One thought that I had, I don't know if this is right, but one thought I had was if you do an opening, if you keep a counter with opening and then you subtract that counter with the closing to kind of match that. So you basically use that, like you kind of push the stack and you pull from it in a way as you go and you get the matching one along the way.
Yep, absolutely. I like that idea. So yeah, we were talking about having maybe 2 counters, but what if we just had one where we add, if we get, opening and then we subtract, we get a closing. That would kind of keep us, keep that sequence going, because if we ever dip negative, then we know that we have too many closing parentheses and we kind of avoid those. So yeah, I like that idea. So let's say keep running counts of parens, and let's say increments for opening, decrement for closing. Yeah, that's a good idea. So I think Stephen mentioned this, I think in his response there. We're going to be kind of implementing something called a stack. This is another data structure. We're going to have a data structures lecture, a good one next week. Sophia Beal is going to come in and talk about data structures. Just understand stack is another data structure. If you've never heard of stack, definitely a good term to Google and understand how it works. On a very simplified description, maybe it's not even that complex. A stack is something called, it's a FIFO data structure. And FIFO basically stands for first in, first out. So if you think about like a stack of plates, for example, if you go to like a buffet, they have a stack of plates. The person adding, like if you're returning a plate, I guess you can return a plate. So this is maybe not the best example, but let's say you have a stack of plates and you're just putting a clean plate on top. Are you going to return a plate? The plate's going to go on top for the most part. You're not going to kind of like wedge it in the middle because that's more complicated. You're not going to put it on the bottom. You're generally just going to put it on the top. The person that wants to take a clean plate is going to take it from the top also. They're not going to just like grab from the middle unless they want to try to do like a magic trick. But yeah, so basically you pile on top and then you take away from the top too. So the most recent plate added is going to be the most recent, it's going to be the first plate taken off this stack of plates, and hence the name stack. The converse, or I don't know, converse, inverse, there's something called a queue, and that's going to
Hunter,
be like,
isn't it a LIFO? A stack's a LIFO. I think you're thinking of a queue.
sorry, yes, sorry.
Sorry.
Thank you. Last in, first out. Sorry. Stacks are, this is a stack and this is a queue. All right, so just to make sure I didn't confuse anyone, we're talking about LIFO for stacks, which is last in. This again, if you are the last plates that get added to the top, you're gonna be the first plate that's taken off and used. So that as a stack is LIFO. FIFO is first in, first out. That is a queue. So that is more like traditional, like if you're at an amusement park and you're waiting in a long line to get to the ride. Well, if you were the first person that got into that line, you should be the first person that gets to ride the ride, right? If it were a stack, I think there'll be a lot of angry people. So yeah, FIFO is where like you're lining up for something. First person in that line will be the first person extracted out of that line. Versus a stack, again, the last item added is going to be the first item pulled off. All right. Yeah, thank you. Sorry, sorry for confusing you guys there, but stack. So that's what we're going to be using. Basically, we're implementing a stack, a very rudimentary stack here by using our counter. So our counter is going to increment basically opening parentheses and add up. And then when we get a closing parentheses, we're essentially saying, all right, this closing parentheses is going to match the most recent opening parentheses that we found. And then we're not actually keeping track of that per se, because we're just incrementing and decrementing. So that's kind of how our counter is working. All right, cool. So, okay, we're going to keep a running count, compare opening. So I think we're just gonna get rid of this. All right, what else do we need to do here? Anything else that you can think of? I think we have a good initial solution here. We're not cover all of our bases, but I think we have a good algorithm. Anything else we need to do here? So we probably need to add characters to our output string. Okay, so basically every other non-friends character is just going to be appended to our string. If you find parentheses characters, we may or may not append them. Okay. I think that seems like a good general game plan. Anyone else think anything we're missing here or anything else we need to add?
Don't we also need to reverse it because we're going to come up with extra opens at the end?
Extra opens at the end. So I think, yeah, we probably need some condition of if our counter goes negative, ignore closing friends. Is that kind of what you're getting at? So yeah, if our counter, which is going up for opening parentheses, if we keep counting down for closing parentheses and then we hit 0, that means it's perfectly balanced. As we have enough opening parentheses to match closing, we get additional closing parentheses, that's going to dip negative because our counter is going to get decremented and go into negative numbers. So yeah, that's a case we definitely want to handle. So yeah, that's definitely important to have. All right, I think this is a pretty good pseudo-coded game plan. So I think we could start coding now. So let's go to our code. I'm not sure if we talked about this pass statement explicitly. I know we've used it a couple times. The pass statement in Python basically says, I have nothing here, but it is taking up a line of code. So if I didn't have anything here, you'd get like a red squiggly. And if you try to run this, Python will say there's an error because this is expecting something in its body. The same thing goes for if we're writing an if statement. Let's say if, some condition, or let's just say X, I don't know, if 8 greater than 9. Let's say I want to code something here, but I don't know what I want to code right now. I'll just write a pass. So a pass is basically like a placeholder, or it's a placeholder for code you're going to add in later. So I could do else, print something, right? So again, the pass statement just takes up a line of code. If you didn't have this here, you'll get an error. It's expecting something in the body for the if statement. All right, so you use the pass keyword to kind of help you code and have some placeholders. All right, balance parentheses. So start with a string. That should be easy enough. So let's say output string equals empty string. All right, str is our input. So let's loop over the input string. Let's do a for s in str. All right, So we're grabbing each character out of our string. I'm going to call it S, and then we want to investigate it. So if is equal to opening parentheses, or S is equal to closing parentheses, we want to do something. Let's see. So let's say if S is opening, we need a counter. As we talked about, we're going to have a running count. Let's create a counter here. Parens. Not sure if I want to call it counter because it's sometimes going up or down, but I'm going to call it counter because I can't think of anything else. Initialize it to 0 because obviously we haven't encountered a closing or opening parentheses initially. So I'm going to initialize that 0 and let's go. All right. So we get an opening parentheses. We want to increment our counter. Parens counter plus equals 1. Else, let me get my terminal out of the way to get more space. Else, if we get the closing one, we want to decrement this counter. Parens counter minus equals 1. Otherwise, if we have anything else, oops, we lift. Else, let's say output string plus equals S. All right, so we have our 3 cases, and again, always get to comments. I'm gonna add some comments here. Opening.
Okay, do you want to? I was gonna say, do you want to add an edge case for the if it's not alphabetic number, just if it automatically pushes that? Because in some of the test cases, there was like numbers in or alphabetic, like A, B, C, stuff like that.
Yeah, so I think that should be covered by this, right? So if we
Else?
don't have opening or closing, everything else will be pushed. Do we have a restriction there? Let me know if I missed something. I definitely could have. Opening increments.
No, that's the easiest way to do it. You're right.
Closing parens.
Ideally, if you have a lot of conditions that you don't need to worry about it, you always want to make it the else condition. It's because it's less code.
Yeah, so I think any punctuation, any letters, anything that's not a parentheses, we're just going to automatically append it. Append all non-parens. We might need to change this approach. Again, just kind of going through our pseudocode example, but I do sense some changes will need to be made. One thing we talked about is if the counter goes negative, ignore the closing parentheses. So we still want to update our counter. We want to update our counter. No, so I think we don't want to keep going negative. So what I'm kind of thinking here is if we're getting extraneous closing parentheses, if we're at 0, we don't want to add those in. We don't want to increment or decrement our counter because future opening parentheses are not going to match up with the closing parentheses before it. Does that make sense? So maybe here we want to investigate if parens counter equals 0, then maybe ignore this character. So let's see. Output string plus equals S. Again, S is our character. If that equals 0, let's maybe continue. So continue is just going to go to the next iteration. Otherwise, we will decrement our counter and then add it to our output string. All right, so let's talk about what we implement, make sure everyone understands what we're doing here. So we have 3 main cases that we came up with. One is if we encounter an opening parentheses, then we want to increment our counter because it's going to need a matching buddy in the future. And then we're going to append it to our output. Secondly, if we get a closing parentheses, we want to check if we have an opening buddy. So the way we check if there's an opening buddy ahead of it is by checking our counter. That counter should be a positive number at this point for this closing parentheses to be valid. If we are at 0, that means that we have no opening buddy ahead of it, and therefore we're going to ignore it with this continue. This continue is basically going to say automatically go to the next iteration here. It's not going to do any of this code behind it. So this should be an S. Again, I think I noticed some problem with our algorithm, but we'll tackle that as we can. Okay, so S and string. Let's
I have
see.
a question about the continue.
Yep.
So if that does equal 0 and it says continue, it will exit out of that loop completely. And is that different from pass? As in, if you put pass in there, it would just go down to the like parens counter.
Yes, so pass would do nothing at all. Pass is like a no operation statement. It just, again, still takes up a line of code. So Python is happy that it has something in there. The two loop keywords that you want to know of, continue, and there's also break. So break, you would use break when you want to exit your loop entirely, as in you're saying, I'm done. I want no further iterations, whether there be, one more iteration left, 20 iterations. I don't care. I just want to exit, like I'm done with this loop. Continue, on the other hand, only aborts the current iteration. So whatever value of S we're investigating, it's just gonna move on to the next value of S, but the loop will continue. As in the next iteration will happen with continue. So if you guys kind of just think about that, it's saying continue the loop, but kind of abort the current iteration. Break says break out of the loop, essentially saying abort the loop entirely. Yep, good question though. All right, so continue is going to basically, it's going to ignore all the code that comes after it. Continue says go automatically to the next iteration on line 16. All right, so I think we have our general approach. I think we handled all these items. Let's change this. The counter is 0. Closing parentheses. We're adding everything else. Return our string. All right, so that's our initial approach. Let's see how our test cases maybe do with this. So I'm going to return our output string, and yeah, let's run our test cases and see how we do. Get rid of fail fast because I want to run them all. Okay, looks like we ran 7 test cases. Let's go up. All right, so we passed, it looks like 5 of them. It might be kind of hard to see on my screen, but we got 5 dots, which means we passed 5 test cases. We've got 2 failures. So we're handling definitely some of the scenarios accurately, it seems like, but we have not covered all of our bases. So the question is, what haven't we covered, or what is our algorithm missing? Again, this is what test development is kind of meant for. We kind of see some progress, but we want to make sure that in the process of fixing those 2 items, again, I don't know what's broken at this point, but in the process of fixing these 2 items, we want to ensure that we don't break our existing functionality. So again, we're going to run all of our test cases again. We're not going to ignore the ones that we're passing in the future, because again, we might break that with some other change. So that's why it's kind of good to have this test suite here. All right, so let's take a look at our, looks like we failed test balance parens empty output 1. It looks like assertion error is expecting, I'm always not sure how to read this. I think it's expecting, yeah, so we're expecting an empty string, but we got a string that has an opening parentheses in it. So let's take a look at test balance parens empty output 1 and maybe kind of glean some information off that. So test empty output 1. All right, so it looks like we failed this test case, right? We're expecting empty string, but it looks like the output, according to my terminal here, we got an opening parentheses inadvertently. So let's actually test this more in detail. So I'm going to go to my main test suite, or my main solution here. I'm actually just going to call my function myself. So let's call output equals balance parens, and then simple test case was closing opening, and let's do a print output. All right, so I'm just going to quickly run this to verify that the test case wasn't lying to me. So I'm going to do Python balance parens.py. Again, this is my main solution, not the test suite. All right, yeah, so the test suite wasn't lying. We do indeed get a opening parentheses, and that is not what we want. So the question is, why is that happening? Now, this is another thing that I hope all of you guys are doing as you guys are coding. Kind of run through your code mentally. Don't just rely on your, on the computer to run through your code and kind of seeing what the output is. Kind of step through it and see what your algorithm is, or what values your algorithm has during execution. So if I kind of mentally do this, my input is closing parentheses, opening parentheses. So let's add a comment here to kind of track that. So we have example, it's closing and opening. All right, so parens counter is going to start at 0. Then we're going to iterate through each character in order, because the string, again, this is essentially a list. So we're going to, it's sequential. We start with the first character. So we go in here. Is S equal to opening parentheses? Nope, we have a closing parentheses. So let's break that down a little more. So first we're going to get that, second we're going to get that. All right, so it's not an opening one, so we ignore this block, right? That one doesn't hit, but then we get this S equal a closing parentheses, and yep, that is what we encounter for our first character. So we're going to get into this block of our if else statement, or else if here. So we're going to check our parens counter. Our parens counter, basically, again, this is preventing, and we probably should have a comment here. Remove extra closing parens. All right, kind of a long comment there, but never hurts to be kind of descriptive here. All right, so we're moving, basically we're ignoring, and the way we're removing is by ignoring it and not appending it to our output string. If our parens counter is 0, that means we don't have a buddy or opening parens buddy ahead of us to match with. So this is going to remove it essentially by not appending it to our output. So I think this is working correctly because our counter is going to be currently 0. We're going to hit our continue, which means we're going to go back to our next iteration. Susan, you have a question?
Yes, I noticed that there are parentheses around your if statement there, if parens counter equals 0. Is this a case when you need it, or was that just a mistake?
That was an unintentional mistake. Like, it's not going to hurt. So if you add them, nothing wrong. This has something in JavaScript, you need those parentheses. So it's, again, a case of coding in Python, but having some JavaScript mentality. In Python, you do not need surrounding parentheses around your condition.
Okay, good.
Yep.
That was what I was wondering. Thanks.
No, absolutely. Thanks. Yeah, definitely ask if there's any confusion or anything that you're just curious about. Yeah, thanks for that question. I always kind of do that because from C++ habit, I'm always, kind of still stuck in that mentality. But yes, in Python, just, it's cleaner syntax, so they don't require you to have those parentheses there. It doesn't change it either way. But yeah, let's keep it clean with Python. So yep, we don't need those parentheses there. But okay, so our first iteration, we had a closing parentheses, we hit this else if, we got to parens counter equals 0, and then we're going to continue because we don't have a matching buddy ahead of it. All right, so then let's get to our next iteration, which is going to be this opening parentheses. Well, we're going to get into this if statement because we have an opening parentheses. We're going to increment our counter, which makes sense because we want to, match it with a closing parentheses later. We're going to append it to our output, and then we're going to continue, and then our string is done, right? We only had 2 characters. So now our algorithm has added this output string, and that's what we return. What have we missed here? As in, what logic do we need to add in here?
If that's the end of the string, then there's not going to be a closing paren after it.
Yeah, so we got an opening parentheses and we automatically appended it to our output string, but we need to know that there's a matching closing parentheses in the future. If we're going to append it right here, there's no way for us to know if a matching buddy exists or not. So this algorithm works in some cases, but it looks like it's missing the case of opening parentheses that has no matching closing parentheses after it.
Okay.
So
I was going to say the one method I tried, I don't know if this is right, but I took a look to see, I used the -1 thing to look at the end of the list and to see if the last character was an open parenthesis, and then basically just removed it if it was. I don't know if that's the right idea here or not, because basically if the end of the list isn't open, then you know that there's no more list left. So you know it's going to basically not be viable at all.
yeah, I think that would be a special case, as in it can catch some cases. So we do an example here. I think what Stephen was saying is if you detect anything at the end that is opening, so if you have opening, if you have an opening at the very end, you know for sure that that one can be omitted because it's the last character and it's an opening. There's nothing after it. However, that's not going to work in all cases. For example, if I have additional characters here, well, this opening one is still extraneous, but the last character is now a C, so that's not going to catch it. So again, that will catch unique case, like special cases, but not every case. And then again, there might be a bunch of extras. So even if we have one that's at the very end, we might have like a series of extras that are kind of in there. Was there another question out there?
Yeah, I have a possible suggestion, but it's based off of a question I have first. Does it matter where the parentheses print out in the string? Does it matter at all?
Yes. So yes, we can't change the order of our input. So again, kind of like high level, maybe think of this as Visual Studio Code as trying to match up your parentheses. Like obviously we don't want to move the parentheses around, but we want to verify that we have balanced parentheses. For example, if I add some parentheses here, VS Code is able to detect that these are extraneous, as in there's nothing matching it. But if I added a bunch of, parentheses here, this would work. It's still going to ask me like, what are you trying to do here? And I guess there might be some other syntactical issues here. But yeah, VS Code is able to detect and identify the extra ones. But again, we don't want to modify the input in terms of the position of the parentheses. So that definitely makes our challenge a little more tougher. But we can get by. All right. So again, this works in some of the cases, but not in all the cases. So we might need something additional here to help us out here. So does anyone have any ideas on how we can maybe identify if an opening parentheses has a future buddy?
I was thinking about, I know that Python has an in function where you can ask Python to kind of like take in a string and be like, hey, if something slice, like the end of the string has this character, then continue.
Okay.
I know it works for arrays, but I'm not sure if it works for lists, but I'm not sure if it works on strings.
Yeah, I do think it will work on strings. However, it's a good idea. I like the thought. So I think what Seth is suggesting is, let's say we're investigating, let me just put in an open parentheses here. I don't know why I typed out said. I think that's just my characters, but all right. So A, B, B, C. All right. So what Seth is suggesting, I think, is let's say we get to this opening parentheses, which may or may not have a buddy. Like this one got closed off, so our counter got set back to 0. Let's say we get another one. I think what Seth is suggesting is search this substring to see if we have a closing parentheses in there. I think that could work, because like if we get here, we find one that we know we have a buddy. Why might this not work? Well, what if we have a case where we have opening here? Let's say, we're investigating this, we're going to search this substring and find a closing buddy. However, if we get to like this opening parentheses, well, we're going to search this substring and still find a potential buddy, but that buddy was paired with someone else. Does that make sense? So like we'll find a closing one, but that closing one actually matches like one of the previous opening ones. So that's a good thought. We might be able to extend upon it, but I think we might need to do something more than just check if there's a closing one or not. Was there a raised hand by someone else?
Yeah, Jonathan has a question.
Go for it. Sorry, I can't always see whose hands raised, so just feel free to ask out loud. You know how to raise your hand, but appreciate the formality there.
Okay, this is probably not the most efficient way to do it, like code volume wise, but since what we've already done worked going forward, couldn't we just do the same thing but going backwards through the string?
So if we went backwards, we'll be able
and
to.
And then if the counter went positive this time, then we would delete the open parentheses.
Yeah, I think
Jonathan, I did it that way. It does work. You double the code, but it works.
Yeah. So again, with these challenges, always try to get to a working solution and then improve upon it. So again, Jonathan, I'm glad you're kind of cognizant of like, well, might that be the most efficient? That's fine for the first pass. So I like that idea. Yeah, let's kind of code that up, and then maybe we could improve upon it. So
okay, I was going to say, if the final output is a positive number, not 0, then that means that we've opened more than we've closed.
Yeah, so that's Michael's thought process was kind of the thought process I had. We still have this parens counter, and we're going to have something positive, which means we have extra opening parentheses. So maybe we could leverage that. So not sure the best way to go here. I'm just going to code up the other solution because I think that could work. Let's just see it in action. So I'm going to do str, reverse it. I guess we can't reverse it because we had to append. Well, if you did the reverse way, how do you append correctly? I guess.
Can you just reverse the string itself and then just call the function on the reverse string.
Oh, you mean call the function twice? So you're saying call.
I use a whole different method, but I was just thinking like that might be at least less work to solve that way.
But won't the string be reversed when you like the output reverse when you get? Sorry.
Yeah, then
yes.
you have to reverse it again, but yeah.
Okay.
Yeah, you just reverse it on the return.
Okay, let's give this a try. So we're gonna reverse. So let's just say input equals. Okay, so I hadn't thought about this idea, but again, always good to kind of have different ideas. So input.
Ankur, just one last thing.
Yep.
str is a keyword in Python. You can't have it as a name.
Like this.
You have to change it.
Okay. I will.
It's the data type in Python.
You're right. It is, but I think you could still have a variable named that. So I didn't run into any issues here, but you're right. We should probably use a better name than str. I'm not sure if there's any compile errors we're gonna have. So I'm gonna reverse this. If you guys remember, slice syntax is a quick way to reverse a string or an array. So this is basically saying reverse it. And then it looks like we want to reverse the output. Okay, so just to go over the suggestion here, we're going to call bounds parentheses, and then we're going to reverse it and call bounds parentheses again so that we chop off extraneous opening ones, I believe. All right. I haven't tried this, but let's see if this works. Got that. Yeah, I'm not sure if that outright's going to work. So basically, I called it with the forward string, and then I reversed it, called it again. There might be a little more to this, so.
I think that's a complicated way to do it. I just did it kind of like the gorilla way, where I just created another string and literally copy pasted, edited, and it worked.
Okay.
Yeah, would your
that's what I was
second
thinking.
output require the output string to go through instead of the input balance parens?
Oh,
string?
yes, you're right. Thank you. Okay, so we did the output, reversed it, but we still got that open one. I think we need to maybe flip these also for the reverse method. Might get a little complicated.
That is correct.
Okay. Okay, so it's a great idea. I'm glad you guys were able to get it to work. I'm going to go down a slightly different path, if you guys don't mind, but not to say that your solution was wrong. Just one I'm not as familiar with. So
No, our solution is not good, but it does work.
yeah, again, getting it to work is the first battle for sure. All right, so inputs, outputs. Let's make sure we're back to what we were before.
Can we just start at the end of the string and after we finish all that and work our way back and delete the number of parentheses while we count down the parens counter?
Yeah, I like that approach. So I think a couple of you guys mentioned it. We do have this parens count, and that is actually going to keep the number of opening parentheses that have been unmatched, right? That's not true for, in this case, for closing parentheses, we automatically chop them off, and we can because it's easier to look in the past. So this code that right here is basically looking in the past and seeing if a closing parentheses has a matching buddy ahead of it. If not, we can 100% know right now, as in when we're at this point in our code, to ignore the closing parentheses. But for future lookup, we got to do this kind of outside of our for loop. So parens counter is going to keep track of how many we have. So first thing we want to do, check parens counter. Put parentheses again. That's what I do, parens counter. If that equals 0, our job should be done. So again, remember we're passing some of our test cases, and that's likely because we didn't have this case where we had unmatched opening parentheses. So if we don't have any unmatched opening parens, our job is done. All right, so if we have our parens counter exactly equal to 0, that means we've equally matched opening and closing parentheses. We can just return our output string. So I think our job is done. However, if we don't have that, we need to do some additional work. This is what's known as an early return. Generally speaking, this is what I prefer. The other way to do this would be I could do if this is not equals and make this into an if statement and put my logic here. But I prefer to kind of just like, if I know I can return and be done with this function, I'll just be done with it rather than always relying on getting to the very end. All right, so if we do have extra opening parens, we need to omit them. All right, so what I'm thinking now is our output string has opening parentheses that we don't want. So what if we loop through that string again for S in output string? We know how many we have, right? Parens counter should tell me how many we have. What if we go, let's see. We do want to go backwards in some sense, as in, let's see. Actually, do we? I guess no, we want to go forward because remember the most recent opening parentheses gets closed by the first found closing parentheses. So the extra ones will be early on in our string. So if we go through this, if S is equal to our opening, then we probably want to omit it. So how do we do this? Let's create another variable, not the best. Let's just use string again. Nah, let's not. Having trouble with naming here. I don't want to name this 2 because that's not a great name. Let's just say balance string equals empty string. And then we're going to go through our output string, which may or may not be balanced. If we find, I guess at this point, it won't be balanced because of this check. But if we find an opening parentheses, we want to decrement our counter. So parens counter will go down by 1. And then we're going to ignore this particular case. So we'll continue. Otherwise, balance parens will get S appended to. All right, so what's going on here is if we encounter an opening parentheses and the counter, we probably need to check. And parens. All right, so if our parens counter is greater than 0, that means we have extra opening parentheses. We're going to decrement our counter, and this continue is basically going to omit it from our output string, which is now balanced parens string.
Don't you need to yank it off of your output string now? Isn't it already on there and we got to pull it off?
Yeah, so I don't like string manipulation, and there are some additional, I guess, overhead or headaches that come when if you modify the thing you're iterating over, it's going to throw off your iterations. So yeah, we could update that one, but I guess in this case, my idea here is to return balance string at the very end instead of output string. So we have kind of intermediate output string, which we're going to go through again, similar to how we did for our input string. But I guess going off of Guillermo's suggestion, I'm just going to rename this. So we have some better naming. All right, so input string. And okay, so now we're doing the same thing, going through another string that we have, omitting opening braces by basically not appending it. So this continue is not going to append. Okay, otherwise we're gonna append it. So again, the case is eventually we're gonna get our parens counter down to 0, and then we're going to continue to add these opening parentheses, as in we're no longer getting into this if block. So we have an opening parentheses, but parens counter is equal to 0. That's totally fine. We want to append those because those are balanced. Okay, so I think that should take care of it. Let's add comments. So ignore, let's say omit, appending.
Maybe I am understanding this wrong, but if you take off the parentheses at the beginning, won't you just have unmatched closing parentheses and then later on unmatched opening parentheses?
Think about that. So take it off at the beginning. I see what you're saying. You're right. Yeah. So I think
we won't get into this statement though if our counter isn't greater than 0.
So I think Kana was maybe going to her example, if I could read her mind, was like if we have something like A, B, C, then a bunch of opening 1. I think Kana is correct. We're going to chop off these, not these. Right? Because we're going in order. And then
yes,
these close off this one. So I think we're going to have to maybe keep track of which ones are matched. Now that's going to be a little more complicated, but we should be able to do it. So how do we do that? We might need to keep track of an index. So yeah, so again, the issue we ran into, which you kind of pointed out, If we have a case like this, these will close off this. So all of these are valid. These are the ones we need to chop off. However, our algorithm here is going to chop off the leading ones and then leave a couple extra at the end. So I think we might need to change our solution a little bit more.
Ankur, what if we initialize this whole thing by counting up how many of each type of parent we have, and then as you go across the string, so okay, in an unmatched closing parentheses, yep, we can ignore that. We get a opening parent. Okay, well, how many closing parents do I have? And we use one basically, and we reduce the number of closing parents we have. And then we continue on and we say, okay, well, here's another opening parent. We're good here.
So sorry, could you elaborate on that? I kind of missed. So are we keeping another counter for closing parentheses, or?
Yeah, so instead, basically open up by just go through and count how many we have. And then as we use them essentially, or get rid of them, we decrement the counter of how many we have left over to use or get rid of.
Isn't that
Ankur, can we take a break?
Yeah, we should definitely take a break. Yeah, so let's take a 9-minute break and we'll solve this post break. But yeah, keep those thoughts handy. Zoom recording. All right, so we ran into a bit of a hurdle here. We were able to implement a solution that covers most of our cases, but we did have this special case that we need to solve here, and that is extra opening parentheses that don't have a matching parentheses or closing parentheses after it. So one idea I had here, so as kind of pointed out, we can't simply chop off the first few parentheses because they might be rematched. So we're going to get a little more complicated here. And this is kind of more implementing a stack that we talked about earlier. So we have this counter. Well, what if instead of this counter, we create a structure that keeps track of our opening parentheses? So we do open parens list. That's just going to be an empty list to start off. So my idea here is this data structure will keep track of the indices for my opening parentheses. The reason I want to do that is so that I know which ones are matched and not matched. And we'll see kind of how that plays out. So parens counter is going to kind of go away for now. I'm going to comment that here. Let me get rid of some of those extraneous comments. All right, so parens counter, we need to replace that with open parens list. And I think you guys should see how this works. Again, the idea of a stack where we're going to actually add things into this container and then pop things off as we want to remove them. So instead of incrementing here, I want to keep track of the index in the output string. And this is important. I don't want to use input string because input string and output string are not going to have the same indices necessarily because we're omitting some characters down here. So open parens list, I'm going to append the index that this is going to take. So maybe just two ways to do this. I could do the length of my string here, length of output string. Again, this will be fine because we're appending afterwards. So, you know, let's say our output string has 4 characters in them, then the character I'm about to insert is going to have index of 4, right? Because we're at 0 base. Maybe that's a little confusing, so I might just switch this to make it a little more clear here. So if I append first, then the index for that item that I just appended is going to be the last index. All right, so again, this is keeping track of the index of the opening parentheses that I just inserted. So let's put a comment, make sure we know, append the index of the opening parentheses. All right, so now that we have that, instead of checking the counter now, we just need to check the length of that opening parens list. All right, so we're still kind of effectively keeping a counter around, but that counter is actually the length of this list instead of just being an integer that's incrementing, decrementing. All right, so we check if that is 0. That means we don't have any opening parentheses that we found so far. Therefore, we're going to ignore any closing parentheses. That logic does not change. Parens counter -1. This is where it gets a little different. Again, instead of just decrementing a counter, we actually want to remove the last opening parentheses that we inserted into this container. So opening parens list, There's a method called pop. Now, if you didn't know that, well, that's where Google comes in play. So if I was like, I don't know how to remove last element from Python list. So that's descriptive enough. Looks like the simplest approach is to use the list pops function. Well, what if I don't know how the pop function really works? Well, let's look up pop list Python. Okay, we got a few responses here. I like W3 schools, so I'm just going to go to W3 schools. So it looks like remove the second element. All right, so if you provide an index, that should remove that particular index. Let's see, optional. So pop takes an optional parameter, that's the position, a number specifying the position of the element you want to remove. Default value is -1, which returns the last item. So this will both remove an item from your list and return it to you. So if I really needed to keep track of the item being returned, I could capture return value. But in this case, I don't really care because I know they're all opening parentheses. So I'm just going to call pop with no value in here, and that's going to by default remove the last item. If I did specify an index here, that would remove that particular item, but I don't want to do that. All right, so pop should get rid of that item because we matched it. We'll append, maybe switch the ordering here to be consistent. All right, so again, our logic here has not changed. We just kind of added a data structure instead of just a simple counter. Here we need to check the length of our data structure. So that was opening friends list, same thing. Logic hasn't changed here. But now down to here, the core problem that we're dealing with is figuring out which opening parentheses to keep and which ones not to keep. And then this is where we can take advantage of having the indices in our open friends list. So let's think about this. We want to match up indices. So what if so the index of output, the indices of output string are stored in open friends list. So we want to omit the ones that are remaining in open friends list. So I think this is where I want to use that enumerate function because I want to grab the index so I can compare the index. So I'm going to use enumerate. Again, if you're not familiar with this function or have questions, Google will be your friend here. But effectively, what this is going to do is give me an index value and the character that I'm investigating. I could probably do this another way. Let's make this maybe a little simpler. I did for I in range. Now I'm just getting the index. Should work either way, but let's just keep it simple. Let's keep our index. All right, so we're doing our range. Again, range is going to iterate from 0 to n-1, where n is this value. So the length of our output string. And now we want to compare output string at index I. That's the same thing as just the character before. And if that equals that, we want to check our length of our data structure here. So we'll do length of open friends list. All right, again, the same general idea, but we have a data structure instead of a counter. We want to pop. So we'll do open friends list dot pop to remove items. But we need to compare an index here. So I still need to make that change, so I will. But let me update my code. All right. So if that equals opening, we want to check something else. So, and we want to check if I in open friends list. All right, so first we're checking, is this an open parentheses? If it is, then we want to search our open friends list and see if that index is in there. If it is, then we want to pop the item and continue on. We want to pop the first item. So how do we do that? Yes. Sorry, trying to think here. Guess we could pop 0. Not sure how efficient that might be, but let's get rid of that one. And okay,
You use shift on Python as well?
Good question. Not sure.
Yes, insert.
Was it?
Insert. It's the same thing.
Insert?
And then, yeah, you can insert at the beginning or via index.
Oh, sorry, I'm trying to remove the first item. So Python.
Oh, yeah, you can do that too. I thought you were, yeah, sorry.
So it looks like it's part of,
You can pop the first item in Python.
yeah, that's what I was going with.
Yeah.
So yeah, I'm just gonna pop the first item. All right, so that's gonna remove the first item because we're going in order, so that should be fine. Continue. All right, I think this should solve it. Obviously, we're gonna test it. But basically, the idea here is we're keeping track of the index, and that index will only exist in here for unmatched parentheses. So it's important that I want to check if it's an opening parentheses first. Obviously, we can not have this check. This would work the same too, because this list will only have indices of opening parentheses. However, doing an operation where we're searching through a list has some complexity to it. As in, if this were like a list that had 100, entries in it, or let's say 1,000,000 entries in it, this is going to have a huge hit on our performance. Therefore, we want to do something that's simpler, as in lower time complexity. So we simply compare our character to opening string. If this is not true, we're going to avoid doing this work. You remember the idea of short circuiting that we talked about on Friday? This and means both sides of this must be true, but the way that our computer, or I guess the way Python will execute this is left to right. So it's going to check this before it's going to check this. So if this is false, it will not even compute this value. Again, this can be expensive, especially if our open friends list, again, had 1,000,000 entries in it. This in operation is not magical. It's actually going to have to iterate through our list and find this particular item. I guess we could check if this is the first item now that I'm thinking about it, because I guess we could do. Yeah, I think we could check the first item because, yeah, now that I'm thinking about it. So maybe everything I said still holds, but I think we're not long going to search through it. So we're just going to check the first item because we're going in order and our open friends list is in order also. So I think that should work for us. But okay, let's test this out. Make sure we are actually achieving our task. So I'm going to clear my console, do Python balance parens.py. All right, notice I got nothing here, which looks like an empty string, hopefully not filled with spaces. But yeah, so that looks like it worked for this particular case. Let's go back to our spec file and kind of test the additional one we have. Like we have this monster test. Let's make sure that that works. And at this point, maybe I want to add some specific test case. So let's actually add one more test case. Let's do a def test. Extra opening friends, because that's the particular case we wanted. Now let's make sure we have a particular test case for that. So I'll go with the example that we kind of drew up while testing. What if we have A, B, C? Let's have one extra here. Let's have 2 closing and then a bunch of opening. So what should happen is everything I've highlighted here is balanced. So this first one should be chopped and everything else should be chopped also because those are extras. So given that, let me just copy what I've highlighted. I would expect our output to be just like that, and we should be good. All right, let's run our test suites. Clear Python balance parent spec. Okay, we ran 8 test cases. Looks like we passed them all. We got some trues out here. I think that's because of this right here. All right, let's run that again to get a cleaner output. All right. Deprecation warning, please use assert equal instead. So it looks like I'm using asserts equals plural. Looks like that's deprecated. Let's make that happy. But otherwise, it looks like we're passing all of our test cases. Again, might be beneficial to add a couple more test cases to be thorough, but I think we're pretty good. Not remove all of them. All right, assert equals looks like they don't want us to use that anymore. So, all right, ran it, 8 test cases. Looks like we're still printing some things out. Not sure where. Do we have a print statement?
At the top of the.
It's in your spec file.
Spec file. All right, those down here. Thank you. You guys are great. All right, just want to clean up my output. All right, run that one more time. Shouldn't change anything. Great. 8 test cases, all passed. I think we're good to go. So again, definitely, I think this was a fun challenge, definitely kind of flexing our algo mindsets. So initial solution worked for the most part, but we had to kind of revise it and add on to it. So the key here at least for my solution, was to add the stack effectively. Again, it's a list, but we're managing it like a stack. So we're adding to the end and popping off from the end as we go through it. Yeah, that was balanced parentheses. Any questions about this challenge?
This just a comment that the balanced parentheses are a variation of this type of challenge. Is a very common interview challenge. Just an FYI.
Ankur, I just wanted to say I'm really fascinated by how you're talking about the different stress that you can put on the system if like you're coming into a big list or something like that by using certain operations over others.
Yep.
Is there a formal way to like benchmark your code against that? Like, so I do something, then I realize, wow, this is like taking a lot of time or it's blowing up or something like that. And then I can like refactor, because like I didn't realize the order of operation was like the and then the, you know, that stuff. So I'm just, maybe we'll cover it later, but I'd love to learn more about it.
Yeah, so I think next week we're gonna go over big O analysis. This is something more theoretical. It's just a way to kind of effectively rate or benchmark your code theoretically. And obviously you could use like profilers to run your code and see how long it's taking to get like actual measurement and see improvements you can make. But yeah, we'll get into big O analysis and algorithmic complexity next week. So it is a topic we'll cover. It's great that you guys are mindful of it. So it's great to see you guys kind of saying, oh, I know this is inefficient, but but I did solve it this way, or, what's the time complexity hit? Great to have that mindset. We'll definitely talk more about that in detail. So, all right, I think that completes our challenge. Took a little longer than expected, but that's totally okay. Let me do a pull request quickly. Otherwise, I think we're good to go here.